I'm Kristof Van Tomme, and welcome to the API Resilience Podcast. If you've ever wondered what it really is we do when we do APIs, and if you've wondered how APIs change organizations, our communities, and our society, look no further. This is the podcast you've been searching for.
In this episode, you can hear a conversation between Kristof Van Tomme and Viktor Farcic. Viktor is a developer advocate at Upbound, and he is also a member of the Google Developer Experts, GitHub Stars, and CD Foundation groups, and published author. He often speaks at community gatherings and conferences. Viktor published the DevOps Toolkit series and test-driven Java development. His random thoughts and tutorials can be found in his blog, technologyconversations.com. He is also the host of DevOps Toolkit YouTube channel and the co-host of DevOps Paradox podcast.
We live in two very different worlds, but the worlds are starting to intersect. And that's really interesting. Can you give a little bit of a background? Like, in what world do you live? And for people that don't know you yet, what do you go to the world with?
My probably most important characteristic is that I was always extremely lazy when things I don't like are concerned. Right, so I spent most of my career trying to figure out how I cannot do something that I don't want to do. Mm-hmm. And that led me a long time ago into automating testing, because that was just silly to me to do the same thing today as I did yesterday. Infrastructure as code, figuring out how to write code itself faster. So all types of ways to avoid doing things I don't like. That's probably the main motivation that followed me throughout most of my career. And right now I'm mostly focused, like many, Kubernetes. The main focus now is how to extend Kubernetes to manage everything.
Because for me, Kubernetes is more of it's a deployment stack. We're on top of Kubernetes. With our Drupal stack, we're working with a hosting partner that is deploying in clusters in a bunch of different clouds. I think the experience landscape for people that are working with APIs, I would say it's probably more of the internal story rather than the external APIs that's you're consuming, or how do you see that?
That's interesting, because if you ask me what is the main characteristic of Kubernetes, now many people would answer to that question and say, hey, that's a thing where I can run applications packages, container images, right? That's the answer of most people. And to me, that's completely false. That's completely misunderstanding what it is. Mm-hmm. If I go back to my own question, what is Kubernetes? Fun sentence, right? It is an extensible API. That's what it is, before anything else. Right? So I see Kubernetes as an API that can be extended. And how you extend it, and with what you extend it, decides what that something is.
Yeah.
Because for most people, Kubernetes is what you get out of the box with Kubernetes. And most people are forgetting that from day one, the idea of Kubernetes was not for people to use it as is. Mm-hmm. It is a base platform on top of which you build stuff, whatever the stuff is. And you build the stuff by extending the API. So I see it as, to me, that's an API story, first and foremost.
I think the reason why I see it as a different world is because there's this barrier between the deployments layer and then this interfacing layer. And like I've been talking about it as platform versus interface, and this is based on Jay Bloom's. Jay Bloom has this three economies model that I find super fascinating. So he has this three economies model where there's the economy of scale, which is like typically the infrastructure team is typically about scale, just making things cheaper by doing a big scale. There's the economy of scope, which is about assets that are being reused over and over again, and assets that become better from reuse, which is a really interesting thing, because normally things don't become cheaper or more valuable from reuse. Platforms actually do that. Like the more people and the more teams are reusing the same assets, the more valuable they become. And then there's the economy of differentiation, which is about creating differentiated things that better capture value with customers. So like creating something that's ideal for a specific customer. Now, Jabe talks about APIs as economy of scope because they become better from reuse. Also, external APIs are there. But what I've seen is that when you're using APIs as a product that you go to customers with, they're actually economy of differentiation. They're about how can you capture more value with your customer by having some sort of interface product that's better fit for a customer's needs. So we typically, like a lot of our portals are external facing, are about differentiation. It's about branding and making something that people will find appealing, will trust, with products that will be right for the job, so that they want to use. And then we also get a request for portals, like platform portals that I call, which are internal facing, that are about making it easier for teams to do their job, like the internal developer experience, making development cheaper by reusing more things. These are two very different animals, even though that I think most people are looking at them from so I've got some API management, I need a dev portal. Let's go find out where we're going to put it. And they're talking about an API portal. More and more I'm learning and talking with people, it's not true, because your platform portal is not just about REST APIs and API management. It's also about your deployment infrastructure and how you're going to use your Kubernetes infrastructure to do things. And this is very, very recently that this differentiation started happening between these two, I think.
It's more that people were not noticing things or even paying attention. Because you said early on that you're using Kubernetes mostly to deploy your applications, right? And now I will make a wild guess, and you correct me at any moment. That means that you have a deployment or a stateful set. That means that you have a service and you have an ingress, right? Now, what is ingress doing? When you create ingress, it creates an external load balancer. It manages infrastructure for you without you even noticing. When you create an application, let's say stateful set, it attaches, if you choose to do so, storage to that application, which again is something completely outside of the cluster. Nothing to do, no direct relation with the cluster or where that application is running. So you are managing both infrastructure and application when you deploy what is perceived as an application in Kubernetes. And then we get projects like KubeVirt, for example, that allow you to manage your application like you normally do, but they happen to run in virtual machines, not containers. And that is still managed by Kubernetes. And what they all do is, think of it this way, Kubernetes has a number of primitives exposed as an API, right? Let's say I'm going to throw a random number of 50. Doesn't matter how close or far that is, right? And then when you install something like Argo CD, KubeVirt, Flux, almost any tool, what they're doing is that they're extending the scope of that API. And say all of a sudden you can say something like, I want to go to the endpoint equivalent of the API endpoint / virtual machine or / GitOps, right? Argo CD application and so on and so forth. So they're all, every single vendor that is currently providing services, tooling, or something related to Kubernetes, which is a significant number of them, they're all extending that API. That's the first thing they do when they do it right? So it is that. But then there is that part of which now jumps from one of the three buckets you mentioned to another, that there is doing something behind that API. Because APIs themselves are useless, right? There is no tangible usefulness in an API by itself. It's just a way how we communicate our desires to some processes behind it. And those two things, extending APIs and something behind it, which we call controllers, they're basically everything. They're 99% of what Kubernetes does. It's actually funny because the authors of Kubernetes, a few of them, very early on said, we made such a terrible mistake. We made a mistake of bundling those things together, meaning APIs and controllers on one hand, and on the other hand, the implementation that is bundled in it, which at that time was Docker. And now it's not Docker, it's Containerd, whatever it is, but running containers. We set back the project for quite a few years by giving a completely false expectation that was never our own expectation to developers or users of that something.
Interesting, because you're right. For me, Kubernetes is like something, container something that we run applications on. I had never perceived it as basically an API or a set of APIs that you can extend. So it's interesting.
You can also look at it from a different angle. I could argue that Kubernetes, in total funding within our industry, and I'm now counting only software vendors, companies that produce software services, something. Kubernetes is probably the place that receives most funding right now. I don't mean funding directly in Kubernetes, but hey, company X is building this. They're focusing on providing that something in Kubernetes, right? And if you think of it from commercial perspective, companies would not do that without that something being completely free and a foundation not owned by anybody. That's kind of clear, but wouldn't do that if extensible API wouldn't be the core feature, the main feature, right? Because all the previous attempts in the industry failed precisely on that component. We had Docker, Docker's Form, Mesos, Nomad, and before that, we had VMware, and so on and so forth. And all of them failed to convince the world, the software industry as a whole, that that's where they should be investing, right? And the reason why that failed, and why, let's say, Internet, World Wide Web succeeded, is precisely because it's designed so that anybody can plug in. Kind of think of it as being ground, Kubernetes being ground, right? On which anybody can put their tiny building, and then that all turns up into a city, right? Whether it's going to scale horizontally or vertically, up or down, whether you're going to dug below it, which direction it's going to go is completely out of control. But the fact that you can extend it is what makes all the difference. And the only way to extend it is actually by extending the API.
Yeah, again, I had never thought about Kubernetes as an open standard. It's like then basically that's like a utility, or the standards that enables computing to become a utility.
Exactly.
Yeah.
Exactly. It's almost like, before, if you move, 20 years ago, the main capability of an operating system was that you can run your stuff on top of it, right? Yeah. Whatever you're building, whatever you're trying to sell, it needs to work on top of it, right? The major difference between that analogy and Kubernetes is that it's not really on top, but it's below it, with the difference that we are extending the surface area for communication, right? All of a sudden, if you go to any random cluster and say, give me the list of all resource definitions, which is essentially, resource definitions are API endpoints, you will get, I guarantee, completely different results in every single cluster. Even within your organization, you have 3 clusters that are running in production, supposed to be the same. You're going to get different results.
But there is a standardization, at least of part of that contract, of that API contract. There's at least there will share a lot of, there will be a lot of commonalities between them.
Yes, so the only way to extend the API is by following certain standard. That's by creating what we call custom resource definitions that need to have API, it needs to have kind, it needs to have metadata and spec. Now, what is inside of spec? Anything you want. Spec is extensible, but everything else needs to follow, not extensible, but can be anything. Everything else needs to follow certain structure. That's one of the big differences between, let's say, Kubernetes and OpenStack. OpenStack never really did not start by figuring out what is the standard, but rather, hey, we have this thing, hey, you, AWS, Azure, Google, VMware, would you like to put your stuff into this thing? And they said yes. And we got a big soup of randomness, right?
Yeah.
Kubernetes is not random. It just can be anything you want, but not random.
My natural habitat is the programmable web, to use that term, of a unfortunately sunsetted website or marketplace, and more of the external facing APIs, where companies are trying to build ecosystems, or they're trying to make money with API calls with whatever data product or digital product they have. There's a lot less similarities between APIs. It's really a zoo out there. Even inside of organizations, it's not just that there's different APIs, it's just that they're not even coherent. It's just different stuff. Does that mean that the Kubernetes ecosystem actually has coherence?
It's huge, vast. So depending on what you put in, it can be anything, but there is coherence. And I think that if I would translate what you just said to something close to my world, I would make analogy to, let's say, AWS API and Azure API and Google Cloud API, completely different, nothing to do with each other, right? Except that they're APIs. And within AWS, most people never got to APIs because they use either CLI or web console or stuff. But if you go to API, you discover that now within one of those, like AWS, every service is completely randomized, right? There is no logic. I happen to work in a project that actually needs to communicate with those APIs. And we made such a silly mistake thinking, okay, there are around almost 1,000 services in AWS. Once we figure out how to, through APIs, create representations of 20, the next 80 will be easier, and the rest of 900 will be extremely easy, right? Because you just keep going. You figure out something that takes time, and then you just keep going and it goes fast. Absolutely not. It's a nightmare, right? Because it's not completely random, but as close to random as it can get. And I'm talking within one provider. Now, if you extend that to Azure, Google Cloud, what's or not? There is no logic. It's not like a language and you say, okay, I understand. I learned first 20 words of English, I can continue, right? No, it's switching from English to Japanese and from Japanese to Hindu, right? There is some root, just as both are APIs, they have get, put, and post and delete, and that's about it. That's where similarities end, right? Kubernetes is trying to change precisely that. It's trying to say everybody's welcome, but we all speak English.
This makes me think of a project from a friend of mine. Basically, their tagline is automatic APIs, so that you would be able to make an API connection like you make a phone call. You just type a number and it figures out what the routing is. It doesn't really matter who you're calling or where you're calling. Like, it's all standardized.
But not if the person on the other side of that line speaks Hindu.
So he has like a mapping model where, depending on the type of API, so if you're doing like an SMS API, then they have a mapping model that will translate from their standards to whatever local stuff that you need to do. Yeah.
That sounds like an amazing project that could never be done.
So they have some success already. So I had not expected to be talking about this, but this is super fascinating because then it basically means that on the internal infrastructure or on the infrastructure side of the world, you have figured out a way of creating coherence in the API landscape. And that was through an open standard that just became the dominant standard, on top of which a whole bunch of other people have built a bunch of stuff.
We're not necessarily there. I'm not in any form of way claiming that everything is standard, because what I'm claiming is that we have a standard extensible API that needs to follow certain rules.
Yeah.
Now, who is plugged into those rules and who is not, that's still pending, right? So not there yet. But we have, let's put it this way, we have the rules of the game.
Yeah.
And now we still need to see who's going to play it, right?
Yeah.
But so far, many players are in it and complying with it.
Another video that I saw that you produced was about, I think it was like, no, it was about security. I think there was one about where basically you explained GitOps and how basically, you no longer need to share keys. You just let just let the machine do the deployments for you. And that was super fascinating and eye-opening also, because I live in a world where it's all about API management solutions. And where you go and get a key to build your application. And it's a whole bunch of stuff is about key provisioning. And here I watching this video, I was like, hey, they don't need key provisioning anymore. And that this is no longer a function of the portal. And it's like, what? that was, and it's like, oh yeah, that totally makes sense, because actually it's just a pain anyway to do key provisioning. But you need a trusted, or at least what I imagine right now from what the limited understanding I have of it, is that you need a trusted environment to be able to do it this way.
You still need some sort of key provisioning, authorization, things like that. I think that one of the big differences that we get with GitOps is that now that is happening in the only place in the world where all the developers agree to be in. Meaning that we can now discuss how you like this and I like that, and your favorite tool is this or that. The only thing that nobody argues about, the single only thing, that's Git, right? That's undisputable that we store stuff in Git. Everything else is up for grabs, right? Everything else can be debatable. And from that perspective, GitOps to me makes a lot of sense, because that's where you live. One way or another, doesn't matter whether you use Jenkins, whether you use Kubernetes, whether you use Grafana, what you use, you inevitably end up in Git. And that's where your workflows are. That's where your authorization is, because you have to use Git completely independently of GitOps and what's not. There are already permissions in place. Who can push to which repository and who can only create a pull request but cannot merge it and stuff like that. That's happening independently of everything else. And then GitOps comes in saying, okay, so there is already that thingy that everybody's using. Why don't we leverage it and do the drift detection from there? Let's start thinking about the desired states of things instead of commands, which happens to be maybe even against human nature in a way. We are so used to say, I want a cluster. I want a database. Create a database, right? How many times did you hear this expression, somebody saying, I want to create a database? And this is very different. This is about stating what you want to have, the desired state, and saying, I would like to have this, and I have no idea whether it should be created, updated, changed, modified, deleted. Not my problem, not my issue. And that in a way converts developers into managers. You're not doing stuff anymore. You're stating your intention, and then Santa's little helpers are going to make that happen. In case of manager, that would be developers, and in case of GitOps, that would be its machines. They're going to figure it out. We started storing desired state there, and then having processes that are making sure that whatever you want is whatever you will have forever and ever and ever. And on top of that, it brings one thing that, just like with Kubernetes, my explanation was kind of maybe not counterintuitive or not so obvious. From my perspective, the main benefit of GitOps is actually security, because all of a sudden, I do not need to have access to my AWS account, to Azure, to my cluster, to this and that. Instead, I have a process somewhere that is pooling information. I can have completely locked down system. Nothing can enter, no ports open, no access to any API, nothing, right? Because the process inside my system is sitting there and pooling stuff in.
It really is a completely different paradigm. And the thing I just learned is that this is also based on the open standard, which is the Git standard, that I did not realize before. And yeah, so I was thinking about, it just, this one thing makes it that internal developer portals are very different beasts, because I think then they become a lot more about discoverability, just figuring out what's out there and who's responsible for it, than it is about, figuring out what you want to use and then getting a key for it so that you can build your application.
I would say that that's one of the two main benefits. The other one is uniformity, meaning that imagine everybody's an expert in something, right? You're very good at something, and then there is everything else. And then traditionally, what we were used to do in companies is say, okay, but if you need this thing, then you can go to this Terraform manifest and you can work with it. You just need to learn HCL, right? And there is AWS console, and you just need to learn AWS, and so on and so forth. So, and that works actually pretty well for your domain of expertise, because you want specialized tools that might be different but are very good at what they do. But then there is 90% of the rest of the things that you somehow want to get, but are not really sufficiently important to you to say, okay, so I just need to go through those 57 different tools and voila, I get it, right? And building those portals enables companies to say, okay, so I'm going to have Kyverno for policy or OPA. I'm going to have this tool for scanning. I'm going to have this and that, because we all have a bunch of things, but you don't have to see all those things unless that's your area of expertise. There is this interface, whatever that interface is. It can be YAML, it can be web UI, whatever it is, where you can see it at the right level of abstraction in a uniform way. And those two things are key: right level of abstraction and uniform way. Because I could argue, for example, Kubernetes itself is not the right level of abstraction, because it's just too low level for you, right? Or AWS, again, not the right level of abstraction. We need something more user-friendly. It's the same thing. To me, it's almost the same analogy like when I go to Amazon to shop for something. Now, if that would have been designed as engineers typically do, I would have an option. Okay, so do you want from Barcelona to Madrid to go by train or by car or by plane? And by the way, there should be a connection from there to Singapore, and then from kind of 57 different options and abstractions in a way, but low level, right? No, you want fast, you want slow. That's the right level of abstraction for me as a consumer of goods, not for me as a truck driver. I will have to have a different interface. It wouldn't work for me, right?
Yes.
But as a consumer, that's the right level of abstraction.
So, and I want to take it a little bit back to ports, and then I have another completely in the field question. What port is doing, because what you explain in your video, and we'll have the link in the show notes, but what port is doing is basically creating a way to template a certain level of abstraction that is being extracted out of all of your resources. Is what it's doing possible because of that level of coherence that we were talking about earlier? Is that the reason why that's possible?
I wouldn't say possible. I would say much easier achievable.
Right.
Because first of all, I do not think that web UI is the right level of abstraction for anything. And with my limited, and I stress limited understanding, that could easily translate to your world like closer to APIs, right? You don't have a randomness on API level, and then you think you're going to organize it by putting a web UI on top of it.
Of course.
API is the right level of abstraction. And if you do it right, then whatever is the user-friendly interface on top of it for people who do not want to communicate with APIs directly, which is a mystery to me, but there are many people, web UIs should be the representation of that rather than something completely disconnected. And if I'm right in that statement, then API comes first, and then you say, okay, how can I visualize that something to consumers of that that API?
So, and I think that's right, especially in the platform side, but I'm not sure that it's right on the external side, because often API are really truly products that are things that you sell. And then you have marketing and sales coming in, adding additional information that was not there in the specification. Sometimes you have affordances of API products that only become visible after customers start using an API, that you're like, okay, here's a couple of ideas of what you could do with this. And those are, especially if you're coming from outside of your coherence space, and hopefully your organization is a coherent space, but even that is not a given, then you need more explanation. You need to be able to add additional information often. At least that's what I'm seeing on the outside.
Yes, I think that, and now I'm translating this to my world, which is less end user focused. I mean, it is end user focused, but my end users are developers rather than my mom and dad, right? There are often multiple layers of APIs before we reach the right level I was talking about, right? Very often I need I need this and that, 57 different endpoints to hit. And I still somehow feel, and correct me if I'm wrong, that I would rather build Uber layer on top of it before I jump into HTML.
It's going to be really interesting because, well, we see like external facing dev portals. We talk about the need for both business and developer personas to be able to use it. But we also see that developer and business personas are merging into technologists, somebody who's sufficiently savvy to understand like a basic modicum of what's happening. So I don't know. I think also like AI is muddying all of these waters again, because when you have AI interpreting APIs, who knows what you still need to. So I've been thinking about this is a whole other podcast, but I've been thinking about AI readiness. Like what do you need to do as an organization to be ready to be for AI to consume your APIs?
You need to jump in right away.
Yes, it's there's no time. We are actually already late. Well, that's a whole other podcast. I wanted to bring it back a little bit to some weird thought that I had. One of the things, actually, it also connects to AI, is that one of the things I've been thinking about is that there's this distinction between the engineered world, which is all the stuff we do in software, which is an attempt to be deterministic. And I say very clearly an attempt, because it's normally not, but because there's a bunch of stuff interacting, and you always have some complex, unexpected behavior that arises. But at least it's the whole, a lot of efforts are being done to make it deterministic. And then there's the coherence side of the world, or this, as long as it doesn't die, it's going to be all right side of the world, and then like good stuff will evolve. And it feels that software is just veering to that side. Like what's happening with AI is that we're getting much closer into this other way of doing things. Now I forgot what the point was that I wanted to make. but how is this connected? Instead of saying do this and do that and do that, and if this happens, then fix it and whatever, you say this is the state, and this is how biology works. There's a steady state, and if your temperature go up, then you have to bring it down. So it really feels like like the engineering world is merging with this biological-like world that is not working in the belief that it can be defined or become deterministic, but it's just like as long as it does what it's supposed to do, it's all right.
Yeah, we're not there yet, but there will always be somebody needs to write that logic that removes those drifts, that reconciles those states. So there is that part, without a doubt. It's just the question that's 1 out of 100, right?
Yeah.
For 99 of us, this is the state I want.
Yeah.
Then for one of us, okay, I need to figure out how to generate logic that will be able to detect those differences and converge those two states into the same thing. Now, that type of work is probably one of the first areas that is going to start disappearing from the human domain, right? Because that's really something that machines are very good at already right now. And then if you put AI over there, oh man, I can easily imagine. I rarely make bets in the future. I can surely bet in not so distant future that our systems will be managed by AIs. Because no matter how much we like defining states right now as engineers, there are simply too many things we don't know how to define even. When I ask an average developer, okay, so how much memory and CPU this should have? The system will ensure that you have that. But how much that is? No idea. Nobody knows. Not nobody, but many of us, right? And that can so easily be fixed with slightly more intelligent systems. I'm not sure even whether it's AI, slightly more intelligent. Go there and make sure that my application never crashes. Is that too much to ask? Right now it is, right? But it works forever and ever. It can serve any number of users. And I can spend my time defining what should be the user experience rather than whether this thing is running.
But this is really a big paradigm shift, I feel.
I don't feel it to be that big. I think that, at least if I stick now to software engineers, I think that we had those paradigm shifts, not same ones, but all the time, right? When people stopped using VI to directly write in terminal and switched to IDEs, that was, we're going to lose jobs. And then when we got drag and drop to create web pages, which never worked, but let's imagine that it did. Now I'm all of a sudden in danger. I spent so much time learning HTML and JavaScript, and now I can drag and drop stuff. Or when AWS came and said, okay, you can just say how many virtual machines you want, and you will get them. Many people that were managing servers in companies also saw it as a massive shift. And by shift, I mean very often feeling of me being in danger, my knowledge not being so valued anymore. And now we have that with AI. Like for a while now, it's been probably a year since I use on daily basis GitHub Copilot, which helps me write code all the time. It's incapable of writing good code, but 90% of my code is not good code. It's not a differentiating feature. It's just stuff that has to be there. One of the phrases I like a lot is that neither things before AI nor AI will replace me or you. People using it will replace me or you.
But beyond the existential threat, it's a different way of thinking about things. It's like the old way of doing things in software was a belief that there is a perfect state. That if I can just manage this, if I can do the best job, or if I can do a great job, then this code will always work without fault. And I will always have the states that I imagine that I want to have. And this is now disappearing. I feel that it's more, instead of having this fragile way of working, because a slight change and the whole thing falls apart, we now are switching to a more resilient way of working, which is saying, well, if it diverts a little bit, that's okay. Just keep things within boundaries, or keep striving for this ideal state.
I feel that we're getting to the conclusion or understanding that ideal state was never a good idea. It's silly. Going back to your previous example of biology, things change all the time. I forgot the name of the singer. There was a concert and Ticketmaster just broke.
Taylor Swift?
Exactly. And so in that scenario, what is that ideal state under which it is working? 1 user, 1 million users, 100 million users? And whatever number you give me, it's going to change next day, next week, maybe next minute. I feel that we are now much more concerned about resiliency in face of constant change, right? So that ideal state doesn't exist. Unless by ideal state we say, my ideal state is that it's working always.
Right. Yeah, exactly.
That's the lowest level of ideal state I can come up with.
Yes, exactly. I'd love to bring it back a little bit again to the whole dev portal space.
Yes.
Because what kind of internal dev portals have you seen beyond the technology stack? So let's forget about technology choices for now, but just what portals have you seen, maybe at customers or somewhere in the community, that you feel like this was a really awesome portal? Like this one, they did a really great job here.
To begin with, I haven't seen many. I've seen much bigger number of horrible portals. And the reason why we get horrible portals is that different groups in companies are very good at, or think that they're very good at really guessing what others need and then building that something and then going back to CTO and asking him or her to mandate that something must be used by everybody because we just invested a year of developing that something. And that failed big time, right? That's why we have a lot of shadow infrastructure, for example, where people would just do stuff completely outside of company policies and tools and what's not, simply because it was built by somebody for themselves and then forced to use by you. There are a couple of things that need to happen in a company for something to become a good portal. First is complete freedom for anybody to use anything. And the reason why that freedom is important is because in that case, people have a choice to use or not use what you built for them. Then you have the ability to measure how successful that is. I just built this and nobody wants to use it. Everybody uses something else. I built something that helps people and they choose not to accept that help. There's something terribly wrong with what I built, which would be the same thing if you go to external world and users, hey, I just built this service, this new way to buy things, shopping online, and nobody's using it, right? And then you fail and you start over. And I think that now we're at a point where that is becoming clearer to companies, that there must be a customer for every single team in a company. No matter whether you're building an ATM and that customer would be a person who goes to ATM to take out money, or that customer is a developer that needs his database for his application up and running. And I feel that now, of course, there are always exemptions, and those who already did it a while ago, but that's something happening maybe last couple of years for real. And a big reason why that is happening now is that, at least when big companies are concerned, there were two different waves happening. One is we build it ourselves. That's what I explained before. And then I build it how I would want it, and then you don't want it, and that's a disaster. And then many companies try to go down the route of using third-party opinionated solutions. Like, hey, if you go to this service X, you will get your application up and running. You just need to click a button, right? That would be like Heroku and similar solutions.
Yes.
And that failed big time as well when bigger companies are concerned. I feel because for you to use an opinionated service, it needs to be doing 100% of what you need.
Right.
Not 90 and not 110, 100, right? Which is impossible goal to accomplish because there is always history in those companies. Hey, I have this thing that was been done like this and like that thing done somehow differently and so on and so forth. So now I think that we're going back to the first phase. We need to build something very specific for us, but this time it needs to be helpful for change.
Yeah.
And that's usually where, I mean, you mentioned already Port, Backstage also. Backstage is precisely the tool for something like that when done right. But I still insist that when done right means that if you actually manage to sort out the mess behind it.
What does a good internal dev portal, what are the main functions for you?
That will depend, again, from the needs of that team, that company, so on and so forth. It will be different. But in ideal situation, I feel that for companies to go fast and do things right, their teams needs to be self-sufficient. And self-sufficient means it's not that I write some code and then you test it and then somebody else will do something else and so on and so forth. We are passing through 7 different teams until we reach production. And then Joe will be woken up in the middle of the night, not me if it fails, right? I think that's the main theme that we need to solve to build those self-sufficient teams. And to answer your question, if self-sufficient teams are concerned, that means full life cycle of their application from the idea all the way until it is running in production, and all that done by same team. It doesn't have to be one person, a team. So that means, how do we define applications? How do we define tests? How do we run tests? How do we deploy? How do we see whether it's working? How do we observe it in production? Is it secure? So it's almost like it's a place where all different experts that were reactive in the past are contributing with their services so that you don't have to open a Jira ticket and say, I need this. You, on the other hand, do not need to call me and say, oh, you have 5,735 vulnerabilities. You shall not pass. Almost like a public square. That's where we all gather to do stuff. And it's usually related to the life cycle of an application. There are things that are silly to put in a portal, because if it's something that you, and when I say you, I mean your team does and doesn't concern me, why would you be in a portal? You already know how to do that. Portal is about communication.
So publishing the pieces that can be reused, so there's going to be maximum reuse in the organization?
Exactly. It's definitely reuse, but I would say that would be the interface of the services that you're offering. Instead of you tell me I'll do it for you, this is the service. Just like what AWS is to me, my portal would be to you in a way. You don't need to call me. You can do it yourself. No need to open a Jira ticket.
This is again the inversion. Instead of asking someone like to go and do something, you just consume the API that does it instead of them.
Imagine if I go back to my previous example, going to Amazon to shop for something. Now, if we would do it from the software industry perspective, where most companies are, that would mean that I would first call one phone to find out the list of available articles in the shoe department. And then they would send me pictures, and then I would call them back to say, I want those shoes. so on and so forth. And after 57 different calls, I would have it done. And that's horrible, not only for me as a consumer, but also for all those people working behind the scenes. They must have better things to do than answer my calls. The reason why hyperscalers grew from nothing to being most valuable companies in the world, like AWS, Azure, Microsoft, right, Google, is because they managed to streamline those processes by not creating but humans not creating virtual machines because you told them to, and exposing it as a service to you. They managed to gain productivity boost that was unprecedented before. And there is no good reason why that shouldn't be applied internally within a company. We all work in companies. We have different types of expertise. How can I convert? So maybe this would be a better explanation. You're an expert in something, whatever that something is, security, database, this. And then you start thinking, how can I convert my experience into code and put that code behind an API? And when I say API, sorry, not API, user interface, whatever the user interface is, so that people can benefit from it. And now I'm going even earlier in our discussion. This is now me being lazy. How can I not actually spend 7 hours a day responding to people's requests? I have better things to do. I should have better things to do.
But I don't. But I feel that the reality for most companies is not that.
The reality is reality, and I'm going to throw random numbers right now. The reality is that we have 10% of the top of the industry, and then in any other industry, you would say, okay, then there is another 10% just below that. No, in our industry, no. There is 10% of the top. There is a huge nothingness. And then there's everybody else. And companies constantly, we have a rate of companies going bankrupt higher than ever before. Survival is optional. There is no guarantee that you will survive. Take a look at the car industry right now, right? You just needed one company, tiny company, Tesla, at that time, to completely change the industry. And because of the rate of how fast changes are happening, is that when you find out that you're disrupted, it's already too late for you to do anything. Now, if we say that software is probably the most important factor in significant number of industries, we need to start treating it like that. And when I say like that, I mean there is no excuse to not live in this century, technology-wise or process-wise.
I've been thinking also about how do you take these paradigms and how do you externalize them? But it feels that there's too much of a fragmentation of the space to do a lot of it right now. The aggregator example I gave, it's kind of like an aggregator. Does that mean that instead we need to have like a really good reason to standardize on certain designs? In Europe, the banking sector was forced to accept open standards, it's open banking standards by the European Commission. And because of that, every bank has to have APIs now. They have to. There's no choice. All these APIs are different, and it's kind of a mess, as you would expect. And as far as I know, there's like a new regulation coming, which is trying to like further standardize these things, so that it will become easier to like have interoperability, or at least this is what I understood from the next initiative. There probably is some other objectives that they have, but I think similar things are happening in the telco sector. They're also working. But they have a history of working on open standards together. Is that the only path that works, or can you cohere in a different way also?
We definitely need standards. I prefer, to be honest, bad standard or exceptionally good 57 standards or 57 implementations. It's twofold, right? We do need standards, but we also do need some kind of simplification. That's me going back to the portal example. Standards are very important for builders, for those who are specifically focused on that something. Because if I'm building a service that will communicate, and I'm guessing now, right, with all those banks, I really don't want to go into all that stuff. Now, that standard is helping me as a builder. It's not helping me as a consumer in any form of way, unless that standard applies to how I get money from ATMs. At least within software industry, we're getting we're getting there faster than with simplification, to be honest. Especially last maybe 5 years, we got a lot of unofficial standards that were done in a way that forced everybody to adopt them. And when I say forced, I don't mean somebody said you have to. That were incentivized in a way that if you don't adopt them, you are actually not going to be my favorite vendor anymore, right?
Yeah, right.
A good example would be OpenTelemetry, which skyrocketed, I think, in only a couple of years. Is essentially a standard way how almost every observability tool, monitoring type of stuff is communicating. And the main reason why that happened, I feel, is that they all realized that it is in their best interest. If we remove the interest from equation, if you say this is a standard because somebody else might benefit from it, the chances of adopting it are relatively small, right?
Right.
So going back to example that I don't literally know, so I'm completely inventing it. Kind of, what's the incentive for the bank in that hypothetical situation to implement that standard API, right? If we figure it out, then of course they will do it.
Right now, it's just you're going to get a fine if you don't. that is just a compliance issue. We were talking to a couple of banks in Switzerland, and I was asking, like, so how far are you in this journey for open APIs? And it's like, we're going to wait and see. We just let all these people figure out how it's being done, and then we'll come in and we'll take the best. So but it's not about standards. I think there's an incentive, and this is where differentiation and platform collide, because in differentiation, like Twilio does not have an incentive to create an open standard for their services that others will implement, because then it becomes easier to switch.
Of course.
So in the different, like, APIs as a differentiated products space, you want to differentiate its specification, because that's a moat that helps you to keep people to give a little bit of a stickiness to the implementations that have been done.
I can also counter. I'm going to play devil's advocate right now, right? When standards of some sorts become truly standard, accepted by everybody willingly, companies start thinking about other types of differentiations, right? They're forced to think about, we all accepted that we will have roads that are this wide each lane, right? You're not going to build a different one. We need to figure out how we can have, faster trucks going through those roads, right? There is always room. It might not be obvious initially, but there is always room to improve on top of it, right? On top, right? Eventually, I think that standards work when they become, from the consumer perspective, and this is important, always from the consumer perspective, when they become table stakes. Like if I go back to the example of OpenTelemetry, of course, many of the big players in the observability market did not want that, right? Because that would remove one of their advantages. So I have better agent to collect data than you and stuff like that. But the moment sufficient number of them adopted it one way or another, and users, their customers, started saying, this is something that must be checked in a checkbox, what happened is that those same companies figured out other differentiating factors. And again, I have no idea how that applies outside the software industry. But those who realize that and start working on implementing those standards, they're actually typically companies that create new differentiating factors sooner than others, right? Because
Yes.
I'm free now to think about what's the next thing I can offer. While at the same time, while I'm thinking that somebody else say, oh, okay, now I do have to do it, right? Now I'm forced to do it. Now I need to focus on doing it instead of figuring out a new competitive advantage. But again, I don't know how much that applies outside of my world. So I might be completely off the mark here, right?
I think it does force innovation and like adding the next layer of differentiation on top. I think that's everywhere. Well, it's interesting, like as a business owner, like trying to navigate all of that, because you're never done. You have to keep going and going and going, and somehow it feels like it's even accelerating.
There is no even, I think.
Yeah.
That word even was wrong in that sentence.
Yes. So worldly mapping is it's a way of trying to predict how technologies will evolve. It's a map of the industrial of the technology landscape. And this is my paraphrasing. So I'm sure somebody else has a much better definition, but the way I understand it, it's basically you have the value chain towards a customer, and then that's one of the axes, and the other axis is the evolution of technology. And with evolution, what is understood is from inception to custom to product to utility. So the premise is that technologies always are moving towards utility, unless there's some blocker somewhere that is stopping them from going forward. And as something reaches utility, like new layers become available on top of that.
Exactly.
That's
very similar to what I had in mind when I said, and then you need to figure out a new competitive advantage.
Then you're definitely gonna like this. It makes it visual. It's something that you can actually map out all the tools that you have and like the pieces of your services that you have, and see like, where is this? Is this inception? Is it or like almost utility? Where are our competitors and what's happening? But making this visible, this commoditization game that basically we're playing, I also believe that it's accelerating, even further accelerating this whole industrialization and commoditization game, because now people are like, oh, so I've got a product. Let's see, how can we turn this into utility?
I think that the speed with which that is happening is accelerating, and that means that you have less and less time to actually do the exercise before you're completely thrown out of the game.
Yeah.
Right? Like, imagine in AI. Now, of course, many companies are going to create solutions, stuff like that, but it's probably already decided who is going to be the top 3 main beneficiaries of that technology. And I can probably already imagine 5 big companies completely going out of the game, because right now it's too late.
Becoming the AI giant, I don't want to even try. But maybe there's ways to enable it or to play into it. There's still plenty of opportunity. I think it's similar to the whole Kubernetes landscape. Like, don't build the next Docker.
Let's say car industry, that your Volkswagen would be equivalent of ChatGPT. Now, a bunch of other industries are formed around Volkswagen, kind of like somebody still makes seats and this and that. So a lot of companies, now is a lot of right time actually for a lot of companies to jump into the AI game, not because they're going to beat Microsoft and Google at the AI game, but because they can make really good businesses being satellites in a way. Fortunately, I'm relatively old. I'm probably going to retire in 15 years or something like that. So otherwise, I would be very worried. How am I going to keep up the pace?
That's then the question is like, does this innovation then become something that humans don't do anymore? Or is it something that becomes so fast that we just can't keep up?
I feel that we are far from that.
It's still a while.
I don't think that we are anywhere close to replacing creativity with machines in any form of way. It might come, I don't know, but that's not on the horizon yet. The problem is that we will be moving into more and more creative jobs, and that means that jobs that are the opposite, mundane, repetitive tasks, are going to be in danger, right? And that's in any industry, right?
Yeah.
Not only software, but any industry. If somebody would ask me for advice, kind of for my career, then my daughter, for example, you should be a designer. When I say designer, I don't mean graphical designer, but kind of like you should be designing things. You should be on a creative side of whichever industry you choose. You should start writing. For her, she's 12. You should learn, no matter what you choose, you should learn how to write code. That's for sure. Even right now, I have certain contacts with people at CERN, and scientists over there write code. Right? That's not their profession. I'm not saying that they're writing code 8 hours a day. I'm not saying that they're the most brilliant developers in the world, but they write code, right? Now, if you go back 20 years in time, and I would say, hey, you're a scientist, you do particle something, and part of your job is to write code, you would probably say that I'm insane. That's a reality now.
Isn't that a snapshot? Because that is code there. Is it the deterministic type of codes that you need, or is it the interface type of codes that you need?
Both. In this context, when I say code, what I really want to say, I have a very strange definition of code to begin with.
Yeah.
To me, code is something that can be interpreted by machines. Now, from that perspective, whether you write Python, you work in Go or JavaScript, or you write YAML file, it's all code. You are capable of instructing machines in an efficient way how to do something.
Is prompting part of that or not yet?
That falls on the efficient part. Probably, potentially. I mean, no code, low code, kind of like writing less code is definitely coming. I'm so impressed with the solution. For example, there is a surge in solutions. Usually they call it no code, low code for, let's say, HR, right? And now we have HR or human resources or whatever we call those teams. Hey, you do not need to hire a team of developers to get what you need. You can do it yourself. Doesn't require that deep level of coding skills to assemble something anymore. And that will become even easier and easier and easier. We might not be typing in terminal for long. That's true. The more machines can understand us, the less effort we need to put into explaining to machines what we need.
I'm still under the impression of a talk I saw this morning that explained why it's now moving so fast, because the way that they explained it was that in the past, there used to be a whole bunch of different types of AI and machine learning. And now they've discovered that actually everything is just a large language model. And you can do images, or it doesn't matter. Just everything is a large language model, which means that all these people are now working on large language models instead of their small, tiny little islands of stuff. And then on top of that, there's a whole bunch of buzz people that jumped also on top of the bandwagon. Incredible speed. That's completely unprecedented. So saying that in the next couple of weeks or months, there's going to be massive discoveries and new approaches, and it's not hyperbole. It's so, and yes, there's the hype cycle and all of that stuff, but still.
Yeah, I mean, if you manage to discard the 90% that is completely pointless, and limit yourself to the 10% that actually does make sense.
I'm sure people that are listening will find something useful from the meandering depths of our conversation. So thank you very much, Viktor. It was a great pleasure to meet you and to have this recording. Thank you for the time you spent on this. thank you for the awesome work you're doing out there in the community. I would recommend anybody who wants to learn more about the Kubernetes API landscape and how that's different or similar to what we're doing in the REST API landscape, to go check out Viktor's work. I'll also put it in the show notes. Your videos are like awesome. They're really well produced. Just enough visual stuff to keep you busy, and you explain it really nicely so that even non-developers like me can understand. So yeah, good work. Keep up the good job.
Thank you.
I recommend everybody to go check it out.
I've really enjoyed this conversation. We should do it again.
Mm-hmm. Yeah.
That's it for this episode. This episode of the Resilience Podcast was brought to you by Pronovix. You can learn more about our company at pronovix.com. And thank you for listening. And until next week.